The Audi R8 racing prototype is on its way to a fourth title, and it's not doing it on luck. While competitors lose time in the pits to technical failures, this car simply keeps moving. 24 hours of continuous high-speed load destroys mechanisms, yet the Germans cross the finish line time after time without a single critical failure. But beyond the racetrack, reality looked different. If you wanted the fastest road-going Audi in the early 2000s, the dealer could only offer you the RS lineup. These were fast and durable machines, but they had one fundamental problem. The engine sat far ahead of the front axle. All-wheel drive combined with a heavy front end delivered maximum stability on straight autobahns. But in corners, physics took over, and that mass inevitably pushed the car toward the outside of the turn. While Ferrari focused on emotion, Lamborghini built aggression, and Porsche defined handling. Audi kept building the correct transport for top executives. Management needed a technology showcase, a halo car. They needed a road-going mid-engine car that would translate Le Mans engineering onto ordinary asphalt and prove that the brand could compete beyond the segment of safe sedans. But here, engineering and accounting collided. Building a mid-engine architecture from scratch for a single niche model meant walking into a financial dead end, because projected sales of a few thousand cars per year would never recoup the budget for developing a new platform. For this car to reach the production line at all, the company had to find another way. My name is Ilya. You're watching Shifted. Today, we'll look at what really stands behind the creation of the Audi R8. We'll trace how cold calculation, a borrowed platform, and hundreds of kilograms of aluminum allowed the Germans to build the perfect supercar, and why this engineering perfection became its biggest problem. From 2000 to 2005, the Audi R8 prototype won Le Mans 5 times. This result was made possible by a mathematical approach to endurance and a unique engineering modularity. The foundation was reliability, but even when components didn't survive the 24-hour marathon, the car's construction allowed mechanics to completely replace the rear axle and transmission in just 4 minutes. While competitors lost hours in the pits, Audi returned to the track almost instantly. But translating this approach to the road car sector proved far more difficult. The most powerful road-going Audi of that era was the RS6 Avant, 450 horsepower and all-wheel drive. But its engine sat ahead of the front axle. Because of this heavy nose, the balance shifted. In high-speed corners, the front tires simply lost grip. All that power turned into inertia, which pushed the front axle to the outside of the corner instead of cleanly cutting the apex. For a car to drive like a supercar, the engine has to sit behind the driver, because that's what delivers proper weight distribution and precise handling. But you can't just take an existing sedan platform and slide the engine backward. Changing the layout requires different suspension geometry, new component mounting points, and a separate structural design for crash tests. Developing a chassis like that from scratch for a production run of 5,000 units is a financial dead end, and the road-going R8 project might have remained nothing more than a set of drawings if the answer hadn't come from inside their own group. In the late 90s, the Volkswagen Group buys Lamborghini, and soon after, the Italians begin developing their new volume production model, the Gallardo. It had a mid-engine layout and an aluminum chassis, exactly the architecture Audi needed. To bypass the financial barrier, management makes the only economically viable decision. The infrastructure has to be shared. Audi takes the platform from the Italian donor as its foundation. The suspension architecture, powertrain mounting points, and transmission tunnel become shared between the two cars. Because of this, the costs of crash testing, certification, and component engineering are split in half. This way, the group gains access to a full supercar platform, bypassing the need to pay for its full development cycle. With a ready base from the Gallardo, the engineers in Neckarsulm could have simply assembled the Italian car with their own logos on it, but they integrated it into their own coordinate system. If the Lamborghini was designed to generate aggression, the Audi R8 was designed for millimeter precision and uncompromising engineering calculation. The R8's skeleton is built using space frame technology. Instead of mass stamping steel sheets, engineers used a spatial frame made of aluminum profiles. Each car contains 99 meters of welded seams, most of them laid by hand. After the welding stage, laser scanners check the structural geometry with an accuracy of 1/10 of a millimeter, a deviation the thickness of a sheet of paper, and the part is immediately rejected. The primary goal was monolithic chassis rigidity. This was necessary so the suspension wouldn't lose a single millimeter of travel, and so that in high-speed corners, the chassis wouldn't flex and transmit false signals to the steering. But the main engineering problem of a mid-engine car is not rigidity, it's temperature. A large displacement, naturally aspirated engine, squeezed into a narrow bay directly behind the driver, generates a critical amount of heat, capable of melting the adjacent rubber and plastic components. To deliver power consistently, the engine needs thousands of liters of cold air every minute, and this is how the R8's most recognizable visual element appears: the side blades. For most owners, they looked like a bold styling move, a contrasting panel cutting across the silhouette. But in reality, they are a tool that works as an aerodynamic trap. They intercept the oncoming airflow along the doors and force it under high pressure directly into the radiators and the intake system. The R8's exterior wasn't drawn by designers in search of beauty. Every line was dictated purely by the laws of thermodynamics and aerodynamics, and the visual aesthetic became only a byproduct of correct calculations. In 2006, when the supercar industry was mass migrating to automated transmissions with paddle shifters, Audi decided to keep the option of a manual gearbox with an open gate shifter. Instead of leather boots or plastic covers, every shift here is accompanied by the physical clack of the lever against aluminum gates. So the driver isn't just sending an electronic command, they're physically closing a mechanical circuit with their own hand. It was a conscious decision to preserve a direct mechanical connection instead of digital efficiency. But the first years of production revealed a certain imbalance. The base 4.2-liter V8 produced 420 horsepower, but the rigid aluminum frame could handle significantly more load. The chassis was designed for sharper reactions and higher speeds, but the engine simply couldn't unlock all of the engineering potential built into the platform. So in 2009, Audi makes a substitution. Engineers install a 5.2-liter naturally aspirated V10 from the Lamborghini Gallardo. With 525 horsepower at base, the car rose to the level of Porsche's track-focused models, while remaining within a competitive price range. But between simply installing an engine and making it run reliably, there's an enormous gap. While Lamborghini tuned their engine for maximum output in short sessions, Audi needed a car with everyday durability. They reworked the engine's thermodynamics so that the V10 could sit for hours in city traffic without overheating. But to make it a track instrument, engineers had to use a dry-sump lubrication system. Because the oil is stored in a separate reservoir instead of a massive pan beneath the engine, they were able to drop the heavy cylinder block as low to the asphalt as possible. This radically lowered the center of gravity, while also guaranteeing that the engine wouldn't experience oil starvation even under extreme lateral loads on track. In essence, the Germans took a complex Italian engine and forced it to behave like a reliable everyday tool. But putting a heavy engine behind you creates a different problem. A mid-engine architecture concentrates mass in the center of the chassis. On one hand, this delivers phenomenal precision through corners. On the other, when a car like this reaches the limit of grip, it snaps into oversteer instantly. And so, all the work of the chassis and the aerodynamics comes down to a single point of physical contact with the road, the wheels and the tires. Every extra gram on the wheel is unsprung mass, inertia that damps the suspension's work and turns an ideal shock setup into a compromise. That's why the original R8 wheels weren't cast from liquid alloy where microscopic voids form. Instead, a solid aluminum billet was pressed under a force of 8,000 tons. That pressure compacts the crystalline structure of the metal, making it exceptionally strong. Only thanks to this strength could high-precision milling machines cut away the maximum amount of excess material, leaving the spokes thin and light, but capable of surviving track loads. No design for the sake of design, the form was dictated purely by function. In 2015, Audi releases the second generation of the R8. The car becomes even more rigid and lighter. Engineers finally abandon the open-gate shifter in favor of the digital speed of an automated gearbox. The car technically moves closer to its new donor, the Lamborghini Huracan. But it's precisely at this moment that German calculations collided with market psychology. In creating the R8, the company had tried to build an everyday supercar, a car that doesn't overheat in traffic, doesn't demand an engine rebuild every 15,000 kilometers, and behaves predictably in any weather. Honda once took the same engineering path with its NSX. The Japanese built a technological instrument that outperformed the Italians on track without demanding constant lift time in the garage. But both of these cars ran into the same paradox. The supercar market is irrational. Buyers in this segment don't pay hundreds of thousands of dollars for engine longevity or urban comfort. They buy drama. They want a sound that intimidates and a character they have to fight with. The R8 turned out too correct, too predictable. In 2024, Audi officially ended R8 production. With this platform, the brand's last naturally aspirated V10 rolled off the line. This model proved to the industry that a supercar can be built for everyday use. Engineers fully isolated every uncontrolled variable, replacing them with flawlessness. But aren't engineering flaws the very thing that give a car its soul?